Hi everyone. As part of your planning memo due before each lab experiment, I've asked you to conduct a hazard review of your experimental plan, which is a key part of ensuring you, your team, and others in the lab remain safe during and after your experiment. To help illustrate some of the thought processes that go into a hazard review, I've recycled a video I made last year in which I conduct a hazard review of a home lab experiment involving alkaline hydroxide solutions. Due to the pandemic, we were all stuck at home, and the students had to do labs in their kitchens, so it was even more important that the students had a well-conceived safety plan, since neither I nor the TAs would be there to intervene. Although the hazards are quite different from what you're dealing with in the UO lab, the underlying steps and thought processes are exactly the same. As with all new experiments involving hazardous substances, a good place to start is with the Safety Data Sheet, or SDS. This outlines the principal hazards of a substance, exposure limits, recommended personal protective equipment, and advice for what to do if there is a spill or accidental exposure. Shown here is the SDS for dry flakes of crystalline KOH. It informs us that KOH is extremely corrosive, causes serious eye damage or skin burns. It's harmful if swallowed. It causes damage to the gastrointestinal tract and respiratory system. It also poses physical hazards. For example, it's very corrosive to metals, and if mixed with water, acid or other incompatible materials may cause splattering and release heat. Precautionary measures should be taken to avoid any contact with your eyes, your skin, and you don't want to get it on your clothing. You also don't want to breathe the dust or ingest it. Important sections of the SDS include recommendations for handling and storage, recommended personal protective equipment, and information about first aid measures if you or others are accidentally exposed. We want to carefully consider all these factors when we assemble our experimental plan. So first of all, we need to think a little bit about where we're going to implement our experiment. For many of us working at home, this will be a kitchen or other shared multipurpose living space. So besides our own safety during the experiment, we need to be thinking about others sharing this space over the next 9 weeks. One of the first things you probably want to think about is where to store the KOH safely when you're not there, and how to keep others from inadvertent harm. KOH is similar chemically to drain cleaner. Would you leave drain cleaner just sitting around where a toddler can open it up and put it in their mouth? No, of course you wouldn't. So this is really the same issue. You need to think carefully about the people in your household who might be at risk of exposure in various circumstances, and then come up with a plan to minimize that risk. In my case, for example, I'm setting this all up in a small bar in my basement, where I have a space to work and access to water and a drain. This bar is in constant use by me and several family members ranging in age from 12 to adult, both for food and beverages, doing homework, and various other recreational projects. I don't want to leave out an open, unlabeled container full of aqueous alkaline hydroxide for someone to stumble across, spilling it, or thinking it's just water and start washing it up in the sink without skin or eye protection, or, worst case scenario, take a drink from it. In order to avoid any issues, I'm storing the dry alkaline hydroxide in its own secondary containment, off the floor and in a cabinet where my dog, who has a tendency to pull stuff off counters and chew on them, can't get to it. The secondary containment ensures all residuals on the container itself is not going to be left behind in the cabinet when all this is done. Also, alkaline hydroxide is extremely hygroscopic, absorbing enough water from the air to turn into a highly concentrated, dangerous corrosive liquid solution if left out. So the secondary containment also ensures the solid remains dry, even if the inner container lid is left loose. I've also decided that when I'm done with any experiments, I'm not going to retain any solutions with alkaline hydroxide in them if I'm not personally there. This way I don't have to worry. The only form in which this stuff is going to be stored is dry in its original container, where it is the least hazardous and most well contained and labeled. Which brings up another very important step. which is to inform others in your household potentially impacted by a hazardous substance about the presence and nature of that hazard. so they're aware and complicit in ensuring safety. In my case, I have kept the dry hydroxide in its original label container with all its danger warnings, and labeled the secondary containment as well. I've also informed others who commonly use this space what's going on. Hey Liam, so over the next couple of days I'm going to be working... Liam! So Liam, over the next couple of days I'm going to be working with some potassium hydroxide over here in the bar. I just want to make you aware of it because potassium hydroxide can be dangerous. So if you see the poison symbols and stuff, you should leave it alone.
I understand.
All right, you understand?
Dad, I'm not a child. I'm not going to just chug some poison. like us, so you also go, ooh, rat poison.
Another issue you should think about is establishing some safety limits on the experiments themselves. Concentrated solutions of alkaline hydroxides are extremely corrosive and dangerous to skin and eyes. So I've also decided to limit the concentration and amount of alkaline hydroxide to levels that'll be easier to handle and neutralize, and they'll be less hazardous if there's a spill. Basically, by limiting alkaline hydroxide concentration, I get a passive failsafe on how bad a spill could be. It's up to you, but I would probably recommend staying below 1 mol, which is 1 mole of alkaline hydroxide per kilogram of water. So one thing I've done in advance is calculate the mass of KOH or NaOH that I'll need for a given amount of water. After I'm done weighing out the dry hydroxide, the rest goes back into storage, where it remains dry. Okay, so that brings us to operational safety. Whenever you're actively working with a hazardous chemical, you want to make sure you're wearing the proper personal protective equipment, or PPE, so that if things go south, you're nominally protected. The SDS tells us that hydroxide is a danger to skin and eyes, and is bad if accidentally inhaled as dust. This means we want to wear gloves, rated for alkaline hydroxide, full eye protection with side shields in case of a splash, and a dust mask. You should probably use a mask dedicated to the experiment rather than your regular COVID mask, since if it becomes contaminated, it will need to be rinsed and dried before you can use it for its regular purpose. You want to put all of this on before you open up the container with the KOH, and keep it on until everything is disposed of or back in safe storage. Another operational issue is containment and disposal, which is best prepared in advance, not improvised later after we already have gotten started and have corrosive liquids all over our hands. What I've prepared here is a bucket with a large volume of vinegar, which contains about 5% acetic acid in water. Acetic acid is weakly dissociating, so it provides a large neutralizing buffer for whatever alkaline hydroxide we add to it. Thus I can use it to quickly neutralize any hydroxide that gets loose on my hands or on any work surfaces. It also provides a place to dump my alkaline solution when done with the experiment. I even have some pH paper ready to verify that the solution remains acidic after adding hydroxide to it. I'm now ready to weigh out hydroxide and make up a solution. Notice I'm keeping the solid hydroxide contained at all times, rather than trying to collect or clean up stray pieces. Most balances have a tare, but if not, we would need to weigh the empty container separately before adding solid, so we could subtract it from the total weight. Pro tip: anything you do, write it down. In the end, keeping good lab records will save you having to redo things later, and it's an important component of good technical record keeping and communication. Another operational safety issue is how to dissolve the dry alkaline hydroxide in the water. Alkaline hydroxide has a large negative enthalpy of mixing with water, and so you'll generate a lot of heat and potentially send splashes of hot caustic into your face if you add water to the solid. It's best to prepare the water first, which has a large thermal mass, and then add the dry alkaline hydroxide to it, rather than the other way around. Any good hazard plan considers the inevitable cleanup in advance. You and/or your landlord don't want corrosive concentrated bases just being tossed down the drain or put in the trash. The best practice with acids and bases is usually to first neutralize them, in this case by washing items in vinegar. And then, assuming a non-hazardous salt as a byproduct, in this case potassium or sodium acetate, we can safely rinse any items in the sink and dispose of items safely in the regular trash. This includes neutralizing any PPE that may have become contaminated by our solution. Finally, we want to neutralize our electrolyte solution in the vinegar and verify that the solution remains weakly acidic before dumping it down the drain. We also want to clean up our workspace completely, leaving no remaining hazards for others. Finally, even if we do everything right, it's still possible a spill or accident could occur. Your plan also needs to include contingencies in case something goes wrong. In my case, I've prepared for accidental skin or eye exposures by working near a sink, where I can get supplies of clean water for diluting any alkaline on skin, as well as a pre-prepared eye wash solution in case anything gets in my eyes. When in doubt, flush it out. I'm also working somewhere with a telephone connection in case I or someone else needs to reach emergency services. Since these contingencies are required in an emergency, they must by definition be planned for in advance, not improvised after an accident has already happened. Hopefully this video helps illustrate some of the thought processes and steps in conducting a hazard review of a new experiment or process, and you find it useful for preparing your planning memos. As always, if you have any questions or comments, please send an email or catch me in the lab.